Hi, today's lesson is entitled The Mole Concept. Many of the lessons prior to today was focusing on individual atoms. However, in the real world and when we're working in the lab, we don't actually deal with atoms, but rather we deal with what's referred to as bulk. So we've got atoms and bulk. Well, there must be some way to relate what it is that we see in lab at the bulk level to what's going on with the atoms at the atomic level. And you're right, there is. Let's use an analogy of counting gumballs in a jar. Perhaps you've seen this at fundraisers or in restaurants. If I were to ask you how many gumballs are in this jar, your strategy would probably be to figure out a small region, count how many gumballs are there, and then figure out how many of those regions might you be able to fit into the glass jar. And then you would make an estimation. Let's say the answer is 41 gumballs. Now let's say we want to repeat that guessing game, but this time, instead of gumballs in the jar, now we have grains of rice. Perhaps you feel like you're still able to do that same method with counting how many grains of rice are in a particular amount or area of the grains of rice or in the jar, and then figure out how many of those areas fit in the jar and do your math. A little bit harder. Let's just say that there's 37,100 grains of rice in the jar, for argument's sake. Well, when we now get to the element or the bulk state of matter here, we can't do that anymore. We can no longer section out and count how many atoms there are. It's impossible. And that's because atoms are so small we can't count them. Let's jot that down so that we can explain this analogy here. As the size of what I'm counting gets smaller or decreases, it gets harder to count them. So does that mean that there's no way for us chemists to figure out when we're working in the laboratory at this bulk level how many atoms there are? No, of course not. Looking back at our analogy, I bet you some of you were saying, no, Mrs. Kurzman, I would not do the grains of rice that way. What I would do is I would actually take the time to count out 100 grains of rice and I'd put them into some kind of container. And then I would get that mass. And when I knew the mass of 100 grains of rice, sorry, I don't want to do grams there, it's grains of rice. If I know what mass 100 grains of rice have, and then I take the mass of this whole entire jar and figure out how many grams or of the bunches of 100 there are, then I can make a better estimate. And that, my friends, is exactly what happens when we're dealing with atoms and molecules at the bulk level and want to translate to what's going on at the atomic level. So to summarize that, atoms are so small they can't be seen, and if they can't be seen, they can't be counted. So there has to be some relationship between how many particles meaning a specific amount, and how much mass that has. That relationship in terms of the how many particles, the specific amount, and the how much mass that has is a known value. The how many particles is the number 602 followed by 21 zeros. 602 followed by 21 zeros. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And that really long number can be shortened to 6.02 times 10 to the 23rd particles. That, how many particles or a specific amount, is also related to how much mass it has. Now, let's go back for a second. If I were to employ in my example here the principle of let's take 100 grains of rice, count them out, put them in a dish, find out how much that mass is. That specific amount is 100 grains. I could do it with my gumballs. I could get 100 gumballs, find out how much that weighs or masses, and then compare that bunch's mass to the total mass. The numbers, though, for the mass of the gumballs and the numbers for the mass of the rice, even though I've counted out 100 of those items, the masses are going to be different because one grain of rice and one single gumball do not have the same mass to begin with. So when we look at this relationship between 6.02 times 10 to the 23rd particles and how much mass that has, because we don't know what we're talking about specifically in terms of which particle, the only way that we can refer to it is the molar mass. And that starts to bring us back to the title of our lesson, the mole concept. In our English language, there are a number of words that have a numerical meaning. In other words, ba-dum-bum-ching, if I heard pair, you know that that means 2. If I said the word dozen, you know that that means 12. Maybe you've heard the word baker's dozen. That translates to the number 13. Perhaps you've memorized the Gettysburg Address and you've heard of 407 years ago. Score is the number 20. I believe there's a popular game called Fortnite. I believe it's really Fortnite in that sense, but I don't know for sure. That is indicative of the number 14. It means 2 weeks worth of time. Well, just like there are these vocabulary words in our everyday language that translate into a number, in chemistry, we have a word, mole, that translates into a number. And that number is 6.02 times 10 to the 23rd. So coming back up here, the 6.02 times 10 to the 23rd particles is equal to 1 mole of particles. And that's going to have a mass called the molar mass. And the 6.02 times 10 to the 23rd particles is how many individual particles will be in the molar mass. Let me go back to what we were talking about before with rice and gumballs, because when I use words that you're familiar with every day, it's going to make more sense. So when I took the 100 grains of rice, and that gave me X grams of rice, and I took 100 gumballs, and that gave me Y grams of gumballs. This mass here, the Y gumballs or the X grams of rice, that's indicative of the molar mass concept here. And the fact that we measured 100 gumballs or 100 grains of rice each time, that's analogous to this part here, the 6.02 times 10 to the 23rd particles, the how many individual things there are. The awkwardness to it is that that bunch, like the exact amount that we're putting into the dish to get the mass of, in chemistry, that's called 1 mole of particles. So if in my example I had said, let's count out 12 grains of rice or 12 gumballs, that would mean we massed a dozen. A dozen means 12. In chemistry, when you have 6.02 times 10 to the 23rd particles, it's called a mole. So it's really important for you not to get bogged down by the words. A mole is just a bunch that has 6.02 times 10 to the 23rd things in it. So just like a dozen roses has 12 individual roses, and a dozen eggs has 12 individual eggs, a mole of carbon atoms has 6.02 times 10 to the 23rd atoms. A mole of water molecules has 6.02 times 10 to the 23rd water molecules. And in terms of knowing how much it masses or how much it weighs, that's going to be the average atomic mass data from the periodic table. Isn't it beautiful how all of our lessons are starting to build and relate to each other? So if I look on the periodic table and I find the molar mass for carbon, or the average atomic mass for carbon, if I put the unit grams after it, 12.01 grams of carbon, that means that it's 1 mole of carbon atoms. And I know it's going to be atoms because carbon is an element. Elements are made of atoms, and it's not one of the Brinkelhoffs. And that means, since I've got 1 mole, there are 6.02 times 10 to the 23rd individual atoms of carbon in that sample. So remember, a mole is a bunch. When you've got 12.01 grams of carbon, you have 1 bunch of atoms that has 6.02 times 10 to the 23rd atoms in it. If I were to do oxygen, 1 atom of oxygen is 16.00, but because oxygen is diatomic, right, we'd have to add 2 of them together. So that gets us to 32 grams of oxygen would be 1 mole of oxygen molecules, because it's diatomic, which means there are 6.02 times 10 to the 23rd molecules of oxygen. Now, if I wanted to figure out how many individual atoms there were, I'd have to multiply that by 2, because every molecule has 2 atoms in it. But now let's get to compounds. The molar mass of compounds. let's take, for example, H2O. This translates to 2 hydrogen atoms and 1 oxygen atom. Well, I'm going to have to look at the average atomic masses on the periodic table to get me to what the total molecule's mass is. All right, again, so what did I do there? The 1.01, that's the average atomic mass of each of my hydrogens, and the mass of 16, that came from the mass of oxygen. So adding them all up got me the molar mass of the compound H2O. Putting that into words, you add all the masses of the atoms in the compound. Giving you a couple of vocab words here, or abbreviations. CMPD is compound. Molecule is MOLEC, molecule. If you wanted to abbreviate moles, you would abbreviate it MOL. So this is the abbreviation, and this is, on the right-hand side, the full word. All right, let's go back for a second. Actually, let me just stop here for this lecture, and then I will elaborate in a different one. Bye for now.